I want to talk to you a little bit about dummy variables, okay, and linear regression, okay, because they're really, really important, and they're actually the only way you can deal with non-continuous variables in your data if you're going to run a linear regression, okay? So if you read in the PowerPoint, there are only two types of variables you can use as independent variables in linear regression. Those are dichotomous, or dummy variables, or continuous variables, okay? So we've got an issue here, okay? So we've got two categorical variables here, female and nationality, okay? So female is actually already set up for us. It's a dichotomous variable, and it's measured as a 0, 1. Okay, so 1 means you're female. You can see the code over here. 1 means you're female. 0 means you're male. Okay, so this means the result is interpreted as the presence / or absence of that variable. Okay, so that's fine. So when we put this in a regression, the effect for being a 1 is the effect for being female, and the effect for if you put 0 in there, the coefficient will disappear. Okay, we have this other variable called nationality. Unfortunately, we have more than two nationalities, so we have Canadians, Americans, and French people today. Okay, you can see they're coded as 0, 1, and 2. Okay, so 0 are Canadians, 1 is if you're from the US, and 2 is if you're French. Okay, so we can't enter this into a regression this way because it doesn't. A continuous variable is interpreted in a linear regression in the sense of each additional unit in X causes this change in Y. That doesn't really make sense when you think about something like nationality. Is being American one more than being Canadian? Some people might argue that. Not saying anything. Maybe the French would say, yes, we're better both than the Canadians or the Americans. But we're not going to say that. Because what we need to do is actually create dummy variables. So as you can see, female already is 1. You get a 1 when you hit that category, female. And a 0 when you're not, okay? So I've actually already created these. So if I can unhide this, except it wants to make a box. Sorry, guys. We want to select, and we're going to delete that box. And now we're going to unhide. Okay? So you can now see I've taken my nationality variable and created 3 new variables. Okay? So I have Canadian. Okay, there are my Canadians. I have Americans. And I have French people. Okay? So you get a value of 1 if you fit that category, and a value of 0 if you don't. Okay? So if you look across these, one way to double check you've done your dummies correctly is that all 3 columns should add up to 1, or 4, or however many categories you have, right? Each one of these has a 1. Okay? So let me just erase this. Okay. So now I'm going to show you how we're going to do this. So Excel has a couple weird quirks about linear regression. One of which, all of your independent variables have to be next to each other. Why? I don't know, because they wanted to. You would find this is different in other software programs. So all I'm going to do is take my nationality variables. I'm going to just copy them, and I'm going to insert them here. Okay, so I just moved them. Okay, so now I'm going to run my linear regression. And my file is put. You can read some of my email. Where did that go? Okay, so now we're going to look at We want linear regression or regression lineaire in French. Okay, so it's going to ask us our y variable, which is going to be our attitude about the magazine. Okay, and our x variables. So years in education, so that's continuous. Female, 0, 1, that's fine. Okay, and then I'm only going to add in Canadian and US. Okay, you might wonder why. Well, whenever we have a categorical variable in a linear regression, we have to leave out one of the categories. Okay, this is the omitted category or reference category. Because you notice, I only have one variable called female. I don't have a variable called male. Okay, so the female coefficient is always interpreted in reference to male. Now, the same thing is going to happen with nationality, is that we're going to interpret the effects for Canadian and US in comparison to being French. Okay? So I have titles present, and I'm going to tell it where to put the data, because I like to be in charge of my analysis. Then I'm going to click OK. Okay, wow. I have a nice fitting regression, actually, right here. So let's talk about this. This doesn't always happen. Okay, so this is R. Okay, this is R squared. Okay, this is just like in a correlation. This is how much variance in the variables is being explained. Almost 93%. Okay, now this is the adjusted R squared, which is taking into account that we don't have a population, we just have a sample. Okay. Okay. You can also see this is our ANOVA, and this tells us, does our model fit better than just the mean? Okay. If this is significant, so if the p is less than 0.05, yes, then your model is significant. It fits better than the mean. Okay. So then we can have our values. Okay. So, all right. So it looks like if we look at this, it's just the constant. So this is if all the rest of your variables were 0, this is what your predicted y would be. Okay, so we can see that education has a negative, okay, because it's negative, but it's not significant. That's really not significant. No, no, no. Okay, it's 0.95. That's horrible. Okay, but we still get the effect that each additional unit of education means that people are less likely to like the magazine. Okay, their opinion goes down. Okay, same thing with women. Here we can see that women are significantly, they're not actually significant. They're less likely to like the magazine than men. Okay, it's negative. It's -2. Okay. It's almost significant. It's not significant in a one-tailed test, but it would be significant in a two-tailed. So you can translate these from a 1 to a 2 by dividing the probability by 2. Okay, so that'll give you a 0.04, excuse me. So it'll be significant. Now we can see that the Canadians are positive. Okay, and also in a two-tailed test would be significant. More likely to like the magazine than French people. Okay? Here, the important thing is we're comparing it to French people because that's the category we left out. Just like with females, we compared them to males. Okay? So it's females are less likely than males, but Canadians are more likely than French to like the magazine. Okay? Same thing with the Americans. Okay? Even higher effect. Okay, they're significantly more likely to like the magazine than French people. Okay, and that's how you interpret that. You might ask, well, how do we know the difference between Canadians and Americans? Well, what you could do is change the omitted category. So instead of leaving out French people and them being the reference, you could leave out the Americans or the Canadians, and then you could see the effect. Okay? So that's some basics on dummy variables and linear regression. All right, talk to you soon.